Hi class, I'm glad you're here and I hope you're doing well. We are going to be looking at how to simplify radicals or square root this week. We're going to do this not just by typing it into the calculator, but actually simplifying it. So we'll start with an easy one that is a perfect square. The square root of 25. 25 is the same thing as 5 times 5. So the square root of 25 is simply 5. And you can get this one on your calculator. Depending on what your calculator is, you might have to, like, if it's on your phone, turn your screen to the side. I have a graphing calculator app here that I like. It actually looks a lot like one of the graphing calculators you can buy at the store. But if I type in the square root of 25, it gives me that the answer is 5. So that's something you should have done that, in previous math classes. What I'm going to show you here today is probably something new. It's how we can simplify something like the square root of 50. If you try typing this into your calculator, it's going to give you a decimal approximation. That is not what we want for this. We want to think about how we can break 50 down into things and then rewrite it as a simplified radical or a simplified square root. There's a couple different ways that you can do this. One way is if you're pretty good with your multiplication facts, you could figure out that 25 is a perfect square that goes into 50. 50 is 25 times 2. So then what you can do is you can take the square root of each of those parts separate. So the square root of 25 is 5, and the square root of 2, you cannot take the square root of 2 and get a rational number. You would get a never-ending decimal, an irrational number, and you would just have to leave that as 5 radical 2. I know I talked about perfect squares a second ago. Let me write these on here. The perfect squares are the list of numbers that you would get if you square each integer. So 1 squared is 1, 2 squared is 4, 3 squared, 3 times 3 is 9, 4 squared is 16, 5 squared is 25. This is the beginning of the list of the perfect squares. So 6 squared is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9, and 10 times 10. So these are the first 10 perfect squares. This list would keep going on forever. So you can always break these down and to figure out which perfect square goes evenly into it, write that number in front, and then whatever number is left over when you divide that out, and then you can simplify the radical that way. I'm going to do a couple more kind of basic ones like this, and then I'll show you a different method. Let's say we want to take the square root of 80. Okay, and let's say that maybe multiplication facts aren't your strongest suit. What you can always do is you can go through this list of perfect squares and just start dividing on your calculator to see which numbers multiply together to be 80. The goal is that we get them to be, at least one of them is a perfect square. So I know that 80 is 8 times 10, but neither one of those are perfect squares, so I'm going to skip that. I'm going to go through and just start dividing by the perfect square numbers. So, because everything can be divided by 1, I'm going to skip that and go to 4. That goes in 20 times. There may be a bigger perfect square that goes into it, so I'm going to keep checking. So 80 divided by 9, oops, I know that that won't work, but just in case, you can always check that and find that it doesn't divide in evenly. But if I try 80 divided by 16, that goes in 5 times. So I'm going to break the square root of 80 into the square root of 16 times the square root of 5. The square root of 16 is 4. I'm talking to my students, Colby. Can you wave? Say hi. Hi.
How are your students?
They're on the internet.
Hi.
Colby says hi. Because they need to learn their math, Colby. He was asking why you're watching this. I hope you're watching this so that you can learn. So this right here would just be the simplified version. The square root of 4 times the square root of 5. One way that you can check to make sure that these are equal, if you have a calculator, you can type in the square root of 80. It is not the answer I want to see when you take the assessment and do the practice, but you can check and make sure that the answer that you get is equivalent. You should get that exact same decimal for each of those. They're the same thing, they're just, this would be simplified. Okay. The other method that you could use to do the same exact problem is, let's say you couldn't find the perfect square that goes into 80. What you could do is make a prime factorization or a factor tree. If you remember doing that probably at the middle school level, you took 80 and you divided it into things that, the factors that go into it. So 80 is 8 times 10, and then you keep breaking it down until you get a list of prime numbers. So 8 is 2 times 4, 10 is 5 times 2, and I can keep breaking this into 2 times 2. I'm going to bring this down, 5 and 2. And then what you're doing is you're looking for like pairs that you can take the square root of. So the square root of 80 is 2 times 2 times 2 times 2 times 5. You have two sets of this. So this here, when you take the square root of 4, you get 2. When you take the square root of another 4, you get another 2. And then you have the square root of 5 left underneath the square root sign. So when you multiply these together, you get 4 radical 5. You get the same answer. I personally like this way better. I feel like it's just less work, and for the level of problems that we're going to be doing, I think this would be sufficient. We're not going to get into any with variables or anything more complicated than this, just because of our circumstances right now. So feel free to join me on Zoom if you have questions. I will also add some links to some other video resources if you want to see more examples. Hopefully this is sufficient for you, and I hope that you guys are just being safe and doing okay. Please reach out to me if you need anything.